Good morning, period 1 and 3. I am still on jury duty. So today you are learning the next lesson, which is lesson 8, 2-6, and the title is called Factoring ax squared plus bx plus c. The objective says we will be able to factor trinomial in which the leading coefficient is not 1. In other words, a, which is the leading coefficient in this trinomial, will not be 1. So we want to take a look at what happened when you have a trinomial in which, different from your last week, all the leading coefficient is not 1. Because last week, you guys have been using the x game to factor all trinomial when there's no number in front of an x squared. Today, you'll be looking at what happened when a trinomial has a extra number that is not 1 in front of the x squared, a squared, b squared, c squared, any square. Again, what happened when there's a number that is not 1 in front of the variable square. So let's take a look at the general idea. Well, previously from last week, you have learned the x game, and to factor trinomial in which the a is 1 with the x game. And to review what's the x game, all you have to do is put the c on top of the x game and the b at the bottom of the x game, and you're going to find two numbers that multiply to get c, and when you add them you get b. So, and then the two question mark will become the two numbers inside the parentheses. If they're positive, I should have put that these question marks are also positive. So instead of minus, these are actually pluses. Like for example, from last week, let's say you learned something, let's say you have something like x squared minus x minus 12. To learn the x game, right, to actually factor it, you're going to create the x game in which the top of the x game is negative 12, which is your c, and the bottom of the x game is negative 1, which is your b. So you're going to find two numbers multiply to get negative 12 and add to get negative 1. Well, the two numbers are negative 4 and positive 3. So therefore, your two factors, the two things inside the two parentheses, are x minus 4 and x plus 3. That's what you learned last week, right? By factoring a trinomial in which the leading coefficient, which is in front of the x squared, is 1, and you're going to use the x game to find the two numbers, which becomes the two numbers inside the parentheses of your answer. Well, today you are going to learn something called star method, which is a developed version of the x game. In my class, I call it the X Factor. It's like a game show where once you learn the game, now you're going to start joining the show. Where on top of the star method, right, I call the star method as well instead of X Factor. Instead of C, you're going to put A times C. And at the bottom of the star method, you still put b just like the x game, but you have an extra divider in the middle, a horizontal divider, in which you're going to put ax and ax on top. And then after that, I'll tell you what you have to do to find the two parentheses that multiply to get the original trinomial. So let's actually use the star method to factor example 1. In example 1, it says factor 6x squared plus 11x minus 4. So we cannot use the x game. We have to use the star method. But always, always, always to do one thing. Before you factor, make sure that you always have to check GCF. Okay, check GCF, because at this point we're gonna factor everything completely. Remember the two words, factor completely, quote unquote completely. That means you always check GCF. So you're going to check it. Is there any common factors between 6, 11, and 4? Well, there's not really any common factor besides 1 that goes into 6, 11, and 4. Then the next thing is you check, well, is there any variables that is common from all three terms? I think I used the word apples, right? Like there's 2 apples here, there's 1 apple here, there's no apple here. And the original question was, well, how many apples can you take it out from all these 3 terms at the same time? And in this case, the answer is you just cannot take out any variables or apples. So therefore, there's no GCF in this trinomial. Well, once you check that there's no GCF, the next step is to create the star method. Well, let's first identify what is A, what is B, what is C? Since you cannot find a GCF, our A is going to be 6, our B is going to be 11, our C is going to be 4. And let's actually review what was the star method. So on the top of the star method, you put A times C. At the bottom, you put B. And then on top of the two dividers, you put AX and AX. So let's actually convert that. Well, first we're going to draw a star method. A times C means 6 times 4. 6 times 4 is 24. Well, here the B is still 11, so we're going to put 11 there. A in this case is 6. You're going to put 6x and 6x. Well, to find these two numbers, the two missing numbers, it is exactly just like the x game. You're going to find two numbers that multiply to get 24 and add to get 11. Well, there's quite some possibilities. You could do, let me write it on the side. You could do 1 times 24. You could do 2 times 12. You could do 3 times 8. You could do 4 times 6. And I believe that's it. And the only possibilities in which you add the two factors to equal to 11 is 3 and 8. 3 and 8. So you're going to put 3 and 8 like this. Now, this is something new. Once you found 3 and 8, do not, I repeat, do not jump straight to your answer. Because I want you to look at these two sides of the star method. They look like a fraction, doesn't it? Because there's a fraction bar. And in the past, when you learned fractions, you were asked all the time to see if you could reduce the fraction. Reduce, I repeat, reduce the fraction. So 6 over 3, right? So when I write 6x over 3, I could simplify 6 over 3 into 2 over 1. In other words, 2x over 1. Well, what about the here? Well, on the right side, you have 6x over 8. Well, and when you reduce 6 over 8, it becomes 3x over 4. Well, the reduced fractions are the two parentheses for your final answer. So, what does that mean? Well, if it's 2x and positive 1, it becomes 2x plus 1. How do I know it's a plus? Because the 1 is positive. Well, how do I know the 2x is positive? Because the 2x is positive. So therefore, this fraction becomes one of your parentheses, which is 2x plus 1. Well, what about the other parentheses? Same thing. So 3x is positive, 4 is positive, so the other parentheses is 3x plus 4. And this is the factor form of 6x squared plus 11x plus 4. How do you check that your answer is correct? Just do the box method or the distributive property and you'll get back the original problem. So that's the easiest way to check your answer. Well, let's try to do another problem. So in example 2, it says factor 3x squared minus 2x minus 8. So just like example 1, always check, can you factor any GCF? So we're going to say check GCF. In other words, does 3x squared minus 2x minus 8 have any common factor between 3, negative 2, and negative 8? Well, besides 1, there's not really any factor. Likewise, we also have to check, can you take out any variables from each term? Well, the first term has 2 apples, the second term has 1 apple, the third term has no apple. Well, I cannot take out any apples or variables from all 3 terms. So therefore, I cannot take out any variables for GCF. So there's actually no GCF. When there's no GCF, then that means your A is going to be 3, your B is going to be negative 2. Do not forget about the negative sign in front of the 2. And C is negative 8. Same thing, do not forget about the sign in front of the negative sign in front of the 8. So let's actually use star method. We're going to draw a x game with a bar, extra bar in the middle of the x game. Remember, the top number is A times C. In this case, 3 times negative 8. So negative, positive times a negative is negative. So negative 24. And then your B, which is the bottom of the star method, it's going to be negative 2. And then on the side, on 2 sides above the extra divider, you're going to put AX and AX. In this case is 3x and 3x. So you're going to find two numbers that multiply to get negative 24 and add to get negative 2. We have 24 again. So there's quite a lot of possibilities. Is it 1 times 24, negative 1 times 24, 1 times negative 24, 2 times 12, negative 12, or negative 2 times positive 12, 3 times negative 8, negative 3 times 8, or 4 times negative 6, or negative 4 times 6. I have to take a look at which one of these, when I add them, I get negative 2. Well, it's going to be this one because 4 plus negative 6 is negative 2. So therefore, those are the two numbers that satisfy this star method, which is 4 and negative 6. The next step is very similar. It's the exact same thing actually. So you have two fractions, right? And you want to make sure that you could reduce the two fractions. Well, let's take a look at this fraction, 3x over 4. Well, you're going to ask yourself, can you reduce 3 over 4? Well, 3 over 4 is already reduced, so you cannot reduce that further. And on the other hand, you have another fraction, which is 3x over negative 6. Well, you could reduce 3 over negative 6. 3 over negative 6, that just becomes 1x over negative 2. 3 over negative 6 is just equivalent to 1 over negative 2. And once you reduce those fractions, those two fractions becomes your parentheses, your factors for the final answer. So one of your answer is going to be 3x plus 4. And then the other answer is going to be x minus 2. You could make the 1 invisible, even though it says 1x. You could write 1x minus 2 or just x minus 2. And those two are the factors of the original trinomial. Again, you could use box method or distributive property to multiply them and see if you get back the original problem. Let's actually work on one where there is a GCF actually. In example 3, it says factor 4a cubed minus 12a squared minus 72a. Well, let's check GCF because it looks like all of them are even number, and not only that, they are all multiples of 4. So when we check GCF, I'm expecting anything other than 1. So we're going to write 4a cubed minus 12a squared minus 72a. Okay, first I know that they're all divisible by 4, so you're going to divide everything by 4, and you'll get 1, you get negative 3, and 72 divided by 4 is negative 18. Looks like the first term has 3 apples, so the second term has 2 apples, and the last term has 1 apple. That means I could take out 1 apple from each of the 3 terms at the same time. So I'm going to take out an apple, so that means the first term has 2 apples left, the second term has 1 apple left, and then the third term has no more apples. Well, once you take out your GCF, your A, B, C, right, the value of A, the value of B, the value of C, is not from the original problem anymore. It's actually from the remaining factor after you take out GCF. So in this case, my A is 1, the B is negative 3, and then the C is negative 18. So do not look at this original problem anymore for ABC. After GCF, you look at the 3 new ABC. And then from there, you use your star method. So at the bottom, we're going to draw a star. So on the top of the star method, you do A times C, which is negative 18. And at the bottom, you put negative 3. Okay. Oh, by the way, I noticed that here that A is 1. So if A is 1, I technically don't have to use the start method. I could actually use the X game. But let's say if you did not notice that, we're going to use both methods and see if you still get the same answer. Okay? Because from the, let's actually finish the star method first. So on here we write AX and AX, which is 1x and 1x, because here A is 1, right? So you're going to find two numbers that multiply to get negative 18 and add, you get negative 3. I get 6 times 3, and it's negative 6 positive 3. So it's going to be negative 6 positive 3. Okay? And the two fractions seems to be already reduced, like 1 over negative 6 and 1 over 3. So it looks like they're already reduced. So therefore, you're going to use those two fractions and write your answer. X minus 6 and x plus 3. And then those are the two factors, but hold on, because I almost messed up. Don't forget about the GCF. So you have to bring the GCF down. It becomes 4a multiplied by a minus 6 and a plus 3. And by the way, it's actually not x to begin with. It's actually a. So we're going to cross out this. Okay. So when you have GCF taken out at first, when you write your answer, you have to carry the GCF. So this is from the hockey stick method, and this is from the star method. But let's say you found out that you noticed that A is 1, and you're like, well, I didn't need to use the star method. I'm going back to the X game. hey, it's the same thing. You're going to put negative 18 on the top, and you can put negative 3 at the bottom, and the two numbers is the same, negative 6 and 3. So aren't these two numbers the same number in the parentheses for your final answer? So when it comes to a being 1, you could actually use the star method or the X game and still get the same answer as long as a is 1. But if a is not 1, just like example 1 and 2, then you cannot use X game. You could only use the star method. Well, let's take a look at the last example in this lesson, which is example 4. It says factor negative 2x squared minus x plus 15. Well, as always, we're going to check the GCF. Always, always, always. Okay. So first, I'm going to put negative 2x squared minus x plus 15 inside the hockey stick method. Well, is there any factor that is a common factor of negative 2, negative 1, and positive 15? Well, besides 1, there's not really anything. But remember, your leading coefficient cannot be negative. So if it says negative 2, you might want to take out negative. In this case, a negative 1. Okay? In other words, you're just going to have a sign change on all three terms. So it's going to be positive 2x squared plus x minus 15. Okay? And I cannot take out any variables from all three terms because the first term has a second power, the second term has a first power, and the third term has no power. So not all the terms has an x, and I cannot take out any x's. So once you take out the GCF, your new a is going to be positive 2, your new b is going to be positive 1, and your new c is going to be negative 15. So we're going to use the star method. So to do the star method, we're going to draw a star for the 4th time in this lesson. The a times c is going to be negative 30. Right? We're just going to make a note, a times c. B is going to be positive 1. And on both sides of the star method, we're going to write ax and ax. In this case, a is 2, so it's going to be 2x and 2x. You're going to find two numbers, multiply to get negative 30, add to get 1. Well, the two numbers that are possible will be negative 5 and positive 6. Because negative 5 plus 6 is 1. So we're going to make sure that these two fractions are reduced. Well, one of the fraction is 2x over negative 5, and it's already reduced, so we're good with this. Well, the other fraction, 2x over 6, is not reduced. So we have to reduce that. So 2 over 6 becomes 1/3, or x over 3. And now this fraction is reduced. So these two reduced fractions are my two answers, or my two parentheses for my answer, in addition to the GCF. So you're going to take out the GCF, right? It becomes negative 1, open parentheses, and in the first fraction, which is 2x minus 5, and in the second parentheses, which is the second fraction, which is x minus 3. And that is your final factor form. Okay, so again, do not forget the GCF. A lot of students will forget the GCF, but do not forget the GCF. Well, that's it. Your homework for today is going to be on Delta Math, which is 2-6, lesson 8, and the title is called Factoring ax squared plus bx plus c. And it says on Delta Math that you have to show work on the star method. If I do not see star method on your paper, you're getting a 0 regardless of what it says on Delta Math. Got it? Thank you.